The last video of Conics is all about systems of equations, but we're going to solve these by substitution and elimination. Now, yesterday we talked about how to solve systems by graphing. We got y by itself and use our graphing calculator to help us solve. But now we're going to do it algebraically. Let's go x squared plus 4y squared minus 4 equals 0. And we got negative 2y squared plus x plus 2 equals 0. Now, in this particular case, we are going to solve by substitution. Oops, I should have put that first. We're going to do substitution. But before we do, let's think about this. This first equation here, what conic section, what conic shape is that going to make? Two square terms, both positive, but different coefficients means this is going to be an ellipse. So this here is an ellipse. And then this one is only one square term, so this is a parabola. Now, without even considering which way it's going to open or what shape it's going to be, what are the possibilities of intersections? We'll have some sort of ellipse, whether it opens left and right like this, or if it's taller, up and down. We could have a parabola like this, or excuse me, an ellipse like this, and then maybe a parabola like this guy. Now, in this case, how many intersection points is this going to have? This has none. All right, but it could be like this. It could have one solution like this. It could have two solutions like this, right? Like these intersection points there. It could be like that. Yikes. It could even be three. How could it be three? Three could be intersect right there at the curve, and then, oops, I didn't draw that very well. But let me draw that differently. What if it was like that? Now it has three. It has a tangent, point of tangency, and two others. All right? Or it could even be four. Could go and intersect like that. So without graphing it, it's tough to tell. But this could have anywhere between 0 and 4 different solutions. Could it have more than that? I don't know. I don't think so. That's something that you could explore, but I'm pretty sure no. But we're going to solve this by substitution. Now, substitution is just like it was with lines. We need to get something by itself. So look at these two equations, and what is the easiest thing to get by itself? And I would argue that this bottom x would be the easiest thing to get by itself. In fact, if I did get this bottom x by itself, we would get x equals 2y squared minus 2. All right, get an x by itself. So once you got something by itself, then you substitute it in to the other equation. So we're going to take this and substitute in for this x right here. So this is going to be 2y squared minus 2. That's going to be quantity squared plus 4y squared minus 4 equals 0. All right, now, because this is squared, we're going to have to FOIL this out. So this is 4y to the 4th minus 4y squared minus 4y squared plus 4. All right, FOILing this out. Then we still have our plus 4y squared minus 4 equals 0. This part right here is this part right here. Okay, so we're going to combine like terms. Combine like terms, we got 4y to the 4th minus 4y squared, because one of the y squares cancels out, and then the 4 is going to cancel, equals 0. All right, just combining like terms. But now we've got to solve this. Now, we got y squares and even y to the 4th, so we're going to have to factor this. Now, whenever we factor, the first thing you always look for is a greatest common factor. So in this case, they both have a 4, and they both have y squareds that come out. And then we're left with y squared minus 4y squared divided by 4y squared is minus 1 equals 0. All right, so we GCF'd. Now, what's left inside the parentheses, can that factor further? This is a difference of squares. This is 4y squared times y plus 1, y minus 1 equals 0. Then we do ZPP. Now, how many y's are up here? There's this set, and there's actually 2 more here, but both of these are going to be, well, what are our solutions here? We get y equals 0. Here, we'd get y equals -1, and y is equal to 1. So there's actually 3 different y solutions here. 3 different y solutions here. So there's actually 3 points. So this parabola, or this graph, would look something like this. And I'm not saying it looks exactly like this, but it has 1, 2, 3 different solutions here. And these are the y values. The thing is, we need to find the x values for each one of these y values. So, to the side here, we're going to talk about what if y is equal to 0. All right, we're going to use this. X equals 2 times, well, y is 0, 0 squared, minus 2. So x would be equal to -2. So when y is 0, x is -2, so our solution here is -2, 0. That's one of our intersection points. What about when y is equal to -1? When y is equal to -1, we said that x equals 2 times -1 squared minus 2. Remember, we're using this here for both of these, and for the third one when it comes up. -1 squared is 2, or excuse me, -1 squared is 1, times 2 is 2, minus 2 is 0. So that means our other intersection point is the point, this is x, 0, -1. And then our third scenario is when y is equal to 1. Again, x is equal to 2 times 1 squared minus 2. 1 squared is 1, times 2 is 2, minus 2 is 0. So our final intersection point is 0, 1. So there are 3 solutions here. Solving by substitution. Now, I'm not going to lie, substitution is not always the best method. Sometimes it is, though. Let's do another example, but this time we're going to do elimination. Elimination. And this works the same way that it did back when we were doing the linear ones. X squared plus y squared minus 16x plus 39 equals 0. And I got x squared minus y squared minus 9 equals 0. Okay, so first of all, what shape is this top equation? This is going to be a circle. Top equation is going to be a circle. The bottom equation is going to be a hyperbola. All right, so somehow these two shapes are going to meet, and we're going to have, well, what are the possibilities? We could have 4, we could have 2, we could have none. There's all sorts of possibilities, right? So, in this particular case, if we're going to look for elimination, now we try and stack everything on top of each other, but on the bottom there's no x term. In this case, it's okay. If I were to add these up right now, would something go away? Would something eliminate? Well, we could multiply by -1 and get the x's to eliminate, but here's the thing. Would all the x's eliminate? Since we have x squared and x, not all the x's would eliminate. However, the y's, right now, if I were to add this up, the y's would totally eliminate. We would have no y squareds, and we would have no regular y's. So we would be left with 2x squared, the y's cancel, the x. We have minus 16x, 30 plus negative 9 is plus 30, equals 0. The y's are totally gone. So now we solve this by factoring again. First thing you look for, GCF. A 2 comes out. X squared minus 8x plus 15 equals 0. Then you factor it further. What multiplies to 15 but adds up to negative 8? 2 times x minus 3 times x minus 5 equals 0. ZPP, and we get x equals 3 and x equals 5. So we have two x values. So does that mean we only have two solutions? Well, maybe. Let's see. Now we have to figure out what the y coordinates are when x equals 3 and when x is equal to 5. Now, which one of these equations to begin with would you want to work with to find y? I don't know about y'all, but the top one has got some big stuff and there's lots of extra x's. I'm going to go with the bottom equations. So when x is 3, I get 3 squared minus y squared minus 9 equals 0, which means 9 minus y squared minus 9 is equal to 0. I'm going to move this y squared to this side. Then 9 minus 9 is 0, so y is plus or minus 0. But here's the thing. Is there such thing as a negative 0? No. So our answer is y is 0. Our solution, or excuse me, our one intersection point is the point 3, 0. What about when y is 5? Again, I'm going to use this equation. So I got, 5 squared minus y squared minus 9 is equal to 0. I'm going to go ahead and move this y squared first. Y squared equals 25 minus 9 is 16. So y squared is equal to 16. In order to unsquare, we'd have to square root both sides. And whenever you use a square root to solve, y is plus or minus 4. Y is plus or minus 4. What does that mean? Well, since it's plus or minus, that means that we're going to get two equations, or two different ordered pairs out of this. We're going to have the point 5, positive 4, and we have the point 5, negative 4. So this actually has 3 different solutions. Now, one way that you could use to check your answers is once you've solved it algebraically, go ahead and graph it. Get y by itself and graph each one. It should look like a circle, and the hyperbola should intersect it 3 times. All right, if you have any questions, bring them to class tomorrow. Smith out!